4 properties, W, X, Y, and Z are ordered from least expensive to most expensive. So we're going to put 4 spots down for each of those properties, 3 and 4. Next, we want to take care of our rules. So Y is the next most expensive property after X. So we have X, then Y. This is a block where we know it takes exactly 2 spaces, right? It's going to take 2 spaces up on our game board. So it could be in 1 and 2, it could be in 2 and 3, or it could be in 3 and 4. Now, we could use the method of drawing each of our game boards out and splitting it on that block. Let's do that. 1, 2, 3, 4. And very quickly, if we were to do that, we would want to put our block in all the possible places it could go. So we could put it in XY, 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 and our second rule says Z is either the most or least. So Z goes in 1 or 4. In other words, it's always good to translate our rules into a language that we can understand and work with very easily. So in this first world, 1 or 4, well, it's not in 1, so we're going to have to put it in 4. The last world, it's not in 4, had to be in 1 and 4, and it's not in 4, so we're going to have to put it in 1. And that leaves who? Well, we've talked about X, Y, and Z, but W didn't get talked about yet. So W gets to go wherever it wants. It gets the circle around it. So we can put W in 3 here because it's not going in 1, 2, or 4. And we can put the W in 2 here. Now, lastly, we have the Z and W in 1 and 4. And so the Z could go in 1 with the W in 4, but they could also switch, right? Because the Z and the W could trade off. Okay, with that in mind, let's tackle our questions. What could be the correct order of properties from least to most expensive? We can check our rules. X and Y go consecutive, and that's going to knock out, 2 of our game boards. Z is first or last. That is going to knock out 2 of our game boards, and that should only leave you with 1 game board. I'll let you figure that one out on your own. What is a complete and accurate list of all of the properties that could be least expensive? Okay, we see, what do we see? We see an X, we see a Z, we see a Z again, and we see the W can switch off with it, right? So that is X, W, and Z. If X is second, how many properties are completely determined? Well, let's find the world that we're talking about. It's not this one, X is first. It's not this one, X is third. Here we go, X is second. Well, what gets forced into place? And careful of that word other. Well, this Y gets forced into place, but the W and Z can still trade off. So we know that the Y is the other property completely determined. One other property completely determined. Each of the following must be true except. Okay, this might be a little tricky. So if something must be true, it's not our answer. X is not the most expensive property. Could that be false? Careful, that's the one at the end. Okay, so can X go last? Well, not here. Not here. Not here. Oh, that's true. Yeah, X cannot go last. So this is not our answer, because if that's a must be true, well then it's one of the 4 must be trues. We need the could be false. Y is not the least expensive. In other words, is it true that Y cannot go first in that least expensive spot? Yes, we have not seen. We cannot put a Y first. Y must go in 2, 3, or 4. Well, why? It's got an X before it. Z is not the 3rd least expensive property. Does that have to be true? Well, if we look in the 3rd most expensive property place, can the Z go there? No, it cannot. So this is also true. Z is not 3rd least expensive. W is not least expensive. Well, is that true? It's not least expensive here, so it's true so far. It's not least expensive here, but here we can definitely put W least expensive. Sure, it could be least expensive. And the last one, if Z is not least expensive, it is the most expensive. Yeah, that's definitely true. Z has to go in 1 or 4. Okay, and last question. If Y no longer was the next most expensive property after X, but rather X and Y were simply ranked consecutively, one before the other, which of the following could be true? So all we're doing is introducing a switch option between the X and the Y, so we can illustrate that like this. Okay, so we just have to remember X and Y, they're still inside of that box, but they are allowed to trade off. Which of the following could be true? Okay, I often tell my students we should focus on the nuances of this rule. This new rule is talking about within the box of X and Y. So that's probably a pretty good place to start looking. And what's different now is that the Y and the X could trade off when they couldn't before. So a could be true question asking us about what could be true now is probably asking us about that Y and X. So Z is second least expensive. No, that's still not true. Y is the least expensive. It's this world right here where we can put the Y first and the X second. X and Y is separated by one property. No, we've been told that they are consecutive. We just don't know the order now. And Z is the third least expensive. No, Z still cannot go third. And W is fifth least expensive is definitely not the case.